Welcome. In this video, we are going to look at whether or not the mean value theorem applies to this given function, and then find any points that satisfy the conclusions of the mean value theorem. Of course, if the mean value theorem can't be applied, then we can't do this part. So let's see if we can apply the mean value theorem. This is our first step. Well, on the interval from -1 to 2, g of x is continuous. If you notice, this has a discontinuity at x equals -2, but -2 lies outside of this interval. Otherwise, this function is a quotient of polynomials. Polynomials are differentiable everywhere, and this quotient of polynomials is differentiable everywhere on its domain. The only spot in its domain, the only point that lies out of its domain is -2, but again, that's not in our interval. So this is also differentiable. Okay, so we know the mean value theorem applies. So the next thing we need to do is find the slope of the secant line that connects these endpoints, also known as the average rate of change. All right, so the average is going to equal g of 2 minus g of -1 divided by 2 minus -1. So this works out to be 2 over 4 minus -1. So 1/2 plus 1 divided by 3. And that works out to be exactly 1/2. So it is 1/2. All right, so next thing we're going to do is evaluate the first derivative of g of x. Then we're going to set this derivative we find, and it's not f this time, it is g prime of x equal to the average rate of change, that is the slope of the secant line on the endpoints. So g prime of x, we need to use the quotient rule. The derivative of the numerator is 1 times the denominator is x plus 2. From that, we're going to subtract x times 1, which is just x, over x plus 2 quantity squared. So this is 2 over x plus 2 squared. Okay, so now let's go ahead and set this derivative 2 over x plus 2 quantity squared equal to 1/2. So if you are new to calculus, I suggest you pause your video and do not restart it until you understand how I figured out this derivative and how I got from here to this value of 1/2 for the average rate of change on the interval. Because now what we're doing is we're taking the derivative we computed and we're setting it equal to that average rate of change. This is equivalent to 4 is equal to x plus 2 squared, or I can write this as x squared plus 4x plus 4 equals 4, x squared plus 4x equals 0. Factoring, we can see that the 2 points we want are x equals 0 and x equals -4. So this tells me that the slope of the line tangent to this function here at 0 and at -4 satisfy the conclusions of the mean value theorem. But before we end this video, we have to ask ourselves, well, are both of these solutions valid solutions? Because if you can see here, 0 indeed lies in this interval, but 4 does not. So in fact, on this interval, the only one that matters, oh, excuse me, not 4, -4, there we are. -4 would be here. So on this interval, the only solution we have which satisfies the conclusions of the mean value theorem is 0. Indeed, if you evaluate this to verify your conclusion. So g prime of 0 is equal to 2 over 0 plus 2 squared, which is 2 over 4. That is indeed 1/2. So the slope of the line tangent to g of x at x equals 0 enjoys the same slope as the secant line through the endpoints of this interval. Graphically, if we use an online tool, I'm using GeoGebra and I'm going into Classic here. Graphically, let's look at this. G of x is equal to x over x plus 2. It is certainly discontinuous here at x equals -2. So our interval was only from 1 to 2. So let me go ahead and shift my view here. I'm going to zoom in. And not from 1 to 2, excuse me, 1 to -1 to 2. So there we are. Here's -1, here's 2. There we are, from -1 to 2. Well, add our endpoints of -1, g of -1, and our other endpoint of 2, comma, g of 2. The secant line between them, we can graph that. And it definitely has a slope of 1/2. An easier way to see it is to tap on it and go here to settings, go to algebra and change that to y equals mx plus b. And clearly the slope is 1/2. And what you figured out that at 0, so 0 comma g of 0, right there, if we have GeoGebra give us the tangent line, oops, that tangent line also has a slope of 1/2. I hope you found this video useful and helpful.